All right, today we're talking about something pretty incredible, a completely new way to get clean water exactly where it's needed, and fast. I mean, forget about those massive construction projects that can take years. We're talking about a complete high-tech water treatment plant that's up and running in just a few weeks.
So that really is the big question, right? When a community desperately needs safe drinking water, or a factory needs to treat its wastewater, the old way of doing things just isn't fast enough. The real challenge is speed. How do you solve an urgent water crisis, like right now?
And believe it or not, this is the answer. The entire system. We're talking all the pumps, all the filters, the complex controls, everything is built and ready to go inside a regular shipping container. It's literally a plant in a box, and it is completely changing the game.
Okay, so let's get into it. What does a plant in a box actually mean? I know it sounds like something out of a sci-fi movie, but this is a very real and very powerful engineering solution that's being used all over the world.
So officially, it's called a containerized water treatment plant. But what you need to know is that these aren't just kits you have to assemble. They are fully functioning, pre-built factories for clean water. Everything is put together and tested in a controlled environment before it ever leaves the factory, which means when it shows up, it's pretty much ready to go.
And the advantages here are just massive. Because it's a standard container, you can ship it anywhere in the world on a truck, train, or boat. When it gets there, you don't need a huge construction site, just a simple concrete slab. You hook up the power and the pipes, and bam, you're treating water. And what if you need more capacity down the line? Simple. You just bring in another container. It's kind of like a Lego-based approach to building critical infrastructure.
But of course, this isn't a one-size-fits-all kind of deal. You could imagine that cleaning up wastewater from a factory is a whole different ballgame than purifying river water for a small town. So how do you know which box is the right one for the job?
Well, picking the right system means you got to do your homework. You have to look at what kind of water you're starting with, how much of it you need to treat every day, and of course, what the local environmental rules are. But here's a big one that people sometimes forget. Who's actually going to run the thing? Some of these systems use really advanced technology, and you need trained operators to make sure they work properly.
So let's get into the nitty-gritty, and we'll start with wastewater. This is where some of the coolest and most innovative containerized tech really gets to shine, especially when we talk about two super advanced biological treatments.
First up, we've got something called MBR, which stands for Membrane Bioreactor. You can think of this as a powerful 1-2 punch. First, the bioreactor part uses helpful microorganisms to basically eat up all the nasty stuff in the water. Then, the water is pulled through these incredibly fine membrane filters, which act like a super tight screen, physically blocking any leftover particles or bacteria. And the result of that process? The water that comes out is exceptionally clean. I mean, it's crystal clear with no solids, no pathogens. It is so clean you can turn right around and reuse it for things like watering crops or for processes in a factory. And in a world where water is scarce, that is a huge, huge deal.
Now, the other major technology is called MBBR, that's Moving Bed Biofilm Reactor. This one works a little differently. Instead of having microbes just float around freely, this system uses thousands of little plastic carriers. Think of each little piece of plastic as a tiny high-rise apartment building for bacteria. They grow a dense film on the surface, which creates this massive army of waste eaters, all packed into a really small space.
So which one do you choose, MBR or MBBR? Well, it really just depends on what you need. If you need the absolute best water quality and space is tight, MBR is your answer. It's perfect for cities. But if you need a system that's incredibly tough and can handle sudden changes in wastewater, which happens a lot in factories, then the MBBR is the way to go. It's just super resilient.
All right, so we've talked about wastewater, but what about the other side of the equation? Turning water from a river or a well into safe, clean drinking water. The process is different, but the plant-in-a-box idea is just as effective.
Inside one of these drinking water containers is basically a complete multi-step purification factory. First, it uses chemicals to make all the tiny dirt particles clump together so they're easier to filter out. Next, a series of advanced filters physically remove everything from fine sand to bacteria and viruses. After that, a disinfection step, usually with chlorine or UV light, zaps any germs that might be left. And for the last step, a final polish makes sure the pH is just right so the water is safe for pipes and tastes great. So yeah, the technology is really impressive on paper, but the more important question is, where is this stuff actually making a difference? Let's take a look at how it's being used out in the real world.
And the applications are just all over the map. These units are absolute lifelines in disaster zones. They can provide clean water just days after an earthquake or hurricane. They're giving remote villages their first ever access to safe drinking water. Industries are using them to clean up specific pollutants. And places like hotels or remote work camps are using them to recycle their own water and become more self-sufficient.
So, okay, let's step back for a second and look at the big picture here. What are the key takeaways from all this, and what might it mean for the future of how we manage our water?
Well, like with any technology, there are pros and cons. The upsides are pretty obvious. They are incredibly fast, super flexible, and take up very little space. But you have to keep a few things in mind. These systems aren't really built to serve a giant city. They're best for smaller, decentralized needs. And, like we said before, the advanced tech inside means you need skilled people to keep them running at their best.
And this is really why all of this matters so much on a global scale. If you look at places like the Middle East and North Africa, where water is already scarce and populations are booming, the ability to deploy these kinds of efficient, high-tech water solutions quickly isn't just a nice-to-have. It's an absolute necessity for their future. And that really leaves us with one last, big question to think about. For centuries, our water systems have been built around huge, centralized plants. But this technology proves that a different model is possible. A network of smaller, smarter, more flexible systems. So, are we starting to see a future where our water infrastructure looks less like one giant mainframe and more like the internet, a distributed, resilient network? It's a really powerful idea, and it might just be where we're headed.